So hello friends, in this video we are going to see why do we use CMOS more than the nmos or pmos, or why CMOS is better than nmos or pmos. We'll see with the small example. We'll design a inverter. We will design an inverter using nmos and CMOS. We'll compare both the circuit and we'll get to know that why CMOS is better than nmos. So this is the circuit of NOT gate using nmos. So inverter using nmos, and this is the circuit designing NOT gate using CMOS. Okay. So in the first circuit, you take first condition when input is high or input is low. Suppose first condition is if the input is low. If the input is low, so NMOS is high voltage sensitive. Means if the input is low, NMOS gets off, NMOS gets turned off, and the output gets plus VCC. Means if NMOS is off or NMOS is open circuit, so current flown through NMOS will be 0, and so the heat dissipation across the resistance R will be 0. So no problem. In case of low input voltage, there is no problem in NMOS circuit. Okay, now you see the CMOS circuit. So if the input is low, so NMOS gets off and PMOS gets on. Okay, so NMOS gets, because of the both NMOS and PMOS in CMOS is in series. If one gets turned off, so current will be 0 and the output voltage will be plus VCC. Okay, and since there is no resistance, so and the no current, so no case of heat dissipation. If you so if you apply input 0, you are getting high output in both the circuit. Okay, so it is the inverter circuit. It is fulfilling the condition for an inverter. Now you take second condition when Vin is high. So if Vin is high in case of the NMOS circuit, so NMOS gets turned on and the current flown through the circuit will be non-zero. So heat dissipation across resistance R will be non-zero. So there will be heat dissipation in this case, and the output gets 0 because NMOS gets turned on. That's why output voltage is grounded and it is 0. So if Vin is 1, output is 0. Okay, fulfilling NOT gate truth table, but heat dissipation occur. But in case of CMOS, if Vin is high, so NMOS gets turned on but PMOS gets turned off. That's why no current flow and output gets 0. Okay, so fulfilling the truth table of NOT gate inverter. But in case of CMOS, there will be never heat dissipation occur. But in case of NMOS, there will be at least one condition where heat dissipation will occur. If input is low, there will be no heat dissipation, but if input is high, there will be heat dissipation. In case of PMOS, the conditions will be vice versa, but in at least one condition in PMOS also there will be heat dissipation. That's why CMOS is better than the NMOS or PMOS. Okay, thank you.